Warm greeting to all. Our project topic is grouped under wealth from the waste. So wealth from the waste out of waste mainly focuses on one among the key factors in sustainable development, that is recycle and reuse. Here we are concentrating mainly on plastic waste. So Bakelite is a commercial name for the polymer obtained from the polymerization of phenol and formaldehyde. So in Coimbatore there are various relay manufacturing industries whose main byproduct is Bakelite. So this waste is too hazardous to the environment and it has been prohibited from disposing it to direct landfilling and open burning at the sites. So a large amount of this waste need a large area for keeping, which becomes a waste management problem also. So the main project of our work is to use a Bakelite as an eco-friendly material in the construction industry. In our research, we developed the products such as paver block, solid blocks and flexible pavement by using Bakelite as a partial replacement for the porcelain. The material has been collected from the railway signal, Porthamur area, Coimbatore. The collected waste Bakelite has some irregularities in its shape and texture, so it has been shredded into small pieces with the help of shredding machine. For the coarse aggregate, the shredded material should pass through 12.5 mm ISC and retain on 10 mm ISC. So this is our first product, paver block. The experimental work has been carried out for a M35 grade of concrete, in which the coarse aggregates were replaced with Bakelite. Natural coarse aggregates were replaced with 6% as 0, 2, 4, 6, 8 and 10% of Bakelite by weight. We have done a test on coarse aggregate for conventional paver block as well as for waste Bakelite paver block. The test result values were aggregate impact value we are getting as 21.7 for conventional paver block and 10.4 for waste Bakelite paver block. Aggregate crushing value we are getting 40.4 for conventional material and 31.4 for waste Bakelite material. Los Angeles abrasion test 48.9% for conventional paver block, 36.6% for waste Bakelite paver block. And a bulk density of aggregate has been checked. We are getting 1577.8 kg per meter cube for conventional material, 1003.3 kg per meter cube for waste Bakelite. So by comparing the result, we are getting a more or less similar result for both the conventional and waste Bakelite paver blocks. So the paver blocks were casted with the dimension of 190 by 170 by 60 mm and tested for bulk density, water absorption and compression test. From the test result, the bulk density of the conventional paver block is 2165 kg per meter cube and waste Bakelite paver block obtained is 2100 kg per meter cube. The compressive strength result after 28 days curing of conventional paver block is getting as 35.8 Newton per mm square and for waste Bakelite paver block is 42.4 Newton per mm square. So from this result, it has been observed that the 10% increase in the compressive strength of waste stabilized paver block compared to conventional block. So from the above findings, it has been concluded that the waste Bakelite up to 8% can be used as a replacement for the coarse aggregate for the manufacturing of paver block. Our next product is solid block using partial replacement of Bakelite. In this product, we are going to evaluate the strength of concrete and the solid blocks. In this, we are going to do the product with various percentage, that is 0%, 5%, 10%, 15, 20, 25 and 30%. So in this things, we are going to evaluate the strength of concrete by using the compressive test. So in this, the compressive test values has been taken at the end of 7, 14 and 28 days. So the dimension of the solid blocks used here is the 380 by 150 into 150 mm. So in this, after casting this solid block, we are going to test the solid block in the three tests, that is bulk density, compressive strength and the water absorption test has been done. So from this results, we have observed that the compressive strength of 4.71 Newton per mm square has been achieved with the partial replacement of Bakelite, and the normal compressive strength, conventional compressive strength has been for solid block is 4.5 Newton per mm square. The bulk density of the solid block used for load bearing unit should not be less than 1800 Newton per mm square. From this present study, it was noted that bulk density of the solid block at the partial replacement of 10% was 1983.56 kilonewton per meter cube. So it is clear that the bulk density has been attained and the corresponding water absorption was 4.71%. Finally, from this product, we have attained that the partial replacement of coarse aggregate with the backlight up to 10% increase the compressive strength of solid block and the required bulk density. And the partial replacement of coarse aggregate with the backlight up to 10% increase of compressive strength of solid block and the required bulk density was achieved. So the backlight can be suitably used for making structural grade concrete and the solid block. So the next project is Bakelite as a surface course with blended materials in the pavement constructions. Flexible pavements are constructed from bituminous or unbounded materials and the stress is transferred to the substrate through the lateral distribution of the applied load with respective depth. The flexible pavements is composed of the bituminous material surface courses underlying or beneath the base and subbase courses. It is widely used in all countries due to its excellent flexible properties built achieved. The natural coarse aggregates are partially replaced with 50% of waste bakelite in subbase course. Our main objective of this project is an alternative approaches has been used such as the replacement of load-bearing materials by the available sources. The first one is to use the waste bakelite as alternate subbase course material in the flux pavement, and then to find out the optimum amount of the bakelite added to the bituminous with respect to carry out the performance test on the different mix proportion. We are taken as the different mix proportionate as with respect to the size of the aggregates. One is the 9.5 mm, the next one is the 4.75 mm, next one is 2.36 mm. To the test conventional flexible pavement as per recording as ISC 37 in 1984, and all the specifications were taken as MAR 2003 recommendation. This experimental investigations was performed to evaluate the strength of pavement structures in which coarse aggregates was partially replaced with bakelite. This research mainly focused on utilization of waste bakelite as partial replacement for coarse aggregate in subbase course in the flexible pavement. The test on the bitumens, the various tests to be conducted in the bakelite as well as the conventional treatments. One is the bituminous test, another one is the aggregate test, the next one is the fine aggregate test. With respect to the test result, one is the softening, bitumen test for softening point. For the test result for conventional, one is for bakelite test is 46.4 degrees centigrade, which is suitable within the permissible limit. And penetration test considered for the bakelite test for 65.6 mm, it should be allowed within the permissible limit also. The ductility test at the maintenance of room temperature 27 degrees centigrade, it should have 98.3 centimeters. It should also within the permissible limit. Finally, the specific gravity of the bituminous at maintaining the room temperature 27 degrees centigrade, it should have 1.01. So the next one is the mixed proportionate of the addition of waste bakelite in the bituminous mix of 9.5 mm, 4.75 and 2.36 mm size of the aggregates. It should be increases, it causes decrease in Marshall value. So Marshall stability to measure the vertical deformation of the specimen, and it should analyze the maximum load required to produce failure when the specimen is preheated temperature. The preheated temperature when it's placed in special test, because the Marshall stability is the progressively taken as based on the dial gauge reading. So dial gauge readings were measured the vertical deformation of the specification. The Marshall stability test for conventional one is 12.1 kilonewton. At the same time, the Marshall stability for the bakelite is 13.2 kilonewtons. And Marshall flow for conventional treatment is conventional experiment result were carried out 3.06 mm, and the bakelite were taken as 3.04 mm. And the air void test can be carried out in convention 4.5%, for taken as bakelite is 4.3%. Then finally, conclude for a void filled with the bitumen's test is 75% for conventional, but in the Bakelite is achieved as 75.3%. So finally, we taken as the failure point of the Marshall stability is 0.25 mm is called the Marshall flow. Then we calculate the pavement evaluation. The pavement evaluation to be considered as the two types. One is the structural evaluation and the another one is the functional evaluation. And based on the structural evaluation, we have using the equipment in Bakelite beam deflection method. The test will be carried out. Finally, we got the result characterized rebound deflection of the test performance of the pavement is 0.982 mm. So which is having less than the value for permissible limit of 1 mm. So hence the result is strong. Finally, conclusion of this project, the optimum binder content is determined on the addition of 10 to 20% waste Bakelite in the bituminous mix. The stability flow and stability values and Marshall coefficients also increases with the addition of the waste Bakelite at 10 to 20%. So in these studies from the standard coarse aggregate and fine aggregate test, it's proved that the waste Bakelite can be used in the aggregate in the flexible pavement. After testing the specimens, it found that the optimum binder content stability and flow value is to be achieved with increasing the addition of 20% of waste Bakelite in the bituminous mix. So and then final conclusion of alternative choice in the construction field, it is recommended that waste Bakelites are shredding into the smaller piece and it can be used in laying of the flexible pavement.